Okay, welcome back. And today we will be going over the most important section for this whole chapter. That is the graph of trigonometry. For this section, we focus on sine and cosine. For next section, we briefly talk about tangent and secant. It's really not that important compared to these two. Okay, so first, let's focus on the graph of sine. And then we use the same logic to get the graph of cosine. Okay. Let's write down what we know. Okay, the first one is, we do know the domain and the range. The domain, we did last time, is going to be negative infinity to infinity. We do know the range. The range is going to be between negative 1 to 1. The reason is because sine t is on this unit circle, which is the y value. So the top is here, the bottom is here, and you cannot go beyond that because you have to stay on the unit circle. Okay, so it's between negative 1 and 1. Moreover, we know sine x is odd. Which means if you know half the side of the sine, you will be able to reproduce the other half by simply rotating that whole thing for 180 degrees. Okay, so we only have to focus on the one from 0 all the way to the positive and do the second part later. The second thing, which is very special, we call it a periodic function. For this reason, think about sine. You can imagine as your sine change from 0 to infinity. Okay, your sine value would go from here to here, all the way up to 2 pi, which is fine. But then they do the same thing again, because after adding a same value for 2 pi, you got exactly the same value. Therefore, you can see this graph repeats itself for every 2 pi. We call this a periodic function with a period. Two pi. We can have another periodic functions with a different period, but basically the core concept is a periodic function is a function which repeats itself after a fixed interval. Okay, this means if we want to draw the graph of sine, number one, we don't have to worry about anything to the left. As long as we figure out anything to the right, we just use the odd function property, we can get the other one. Second, even for this one, we can cut it into intervals of 2 pi, 4 pi, 6 pi. And as long as we figure out the shape here, all other shapes will be exactly a copy of this, and you copy it for every single 2 pi you have because you repeat all your values for your function. So this really helps us to narrow down to figure out the graph of sine between 0 and 2 pi, and then we can get everything after 2 pi by periodic property. Then we can get everything before 0 by the property of odd function. So we finish the whole graph. Okay, with that in mind, now the third thing, let's try to draw it. Whenever you try to draw something, the first thing came to your mind is probably, which is the easiest but also stupidest thing, is plug in some numbers, right? For some numbers, you do know the value. So do you know some easy numbers that you know the sine value? Well, if I put t here, I put sine t here. Quickly, sine 0. 0. Sine pi over 2. That is going to give you 1, which is the maximum, by the way. 0, if you have pi. 3 pi over 2, you have 0. a 1. And then finally 2 pi, you go back to 0, which you have 0. That's why you call it periodic. This one and this one is definitely going to be the same because you have a complete 2 pi. All right, let's put them on the graph. But this time we put t on here, not x and y anymore. We put your sine t here. At the 0, you are 0. At pi over 2, pi, 3 pi over 2, and 2 pi. That's pi over 2 for each interval. It's equal intervals here. Now you are here, you are here, 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 and here. Okay. You pass these 5 points. That means also you pass these 5 points. And just keep going, keep going, keep going, because you repeat yourself, right? Finally, roughly, going from 0 to pi over 2, what do? That means you have this t goes from here all the way starting from here to here. Can you see going from here to here and before 1, this one keeps increasing. Okay, and then starting from 1, what happened? You go from 1, you go from pi over 2 to pi, which is here. Your y value, which is your sine, start to decrease, and all the way eventually you got 1. Okay. Similar idea, starting from here all the way to 3 pi over 2, you start to decrease, and eventually at -1, and finally, starting from here to here, you go back again. I may not be drawing this one exactly accurate, but roughly the trend is like this, right? You have these 5 points. For the first quadrant, you go all the way up, your sign keep increasing until you reach 1, that's your maximum. Starting from quadrant 2, you're still positive, but you're decreasing until you reach pi, which is 0. You keep decreasing, but you cannot go exceed -1, and finally you come back. That's roughly the graph for 0 to 2 pi. And if that's the case, that's for 2 pi to 4 pi. That's from 4 pi to 6 pi, and just keep repeating. And if that's all you have, and this one need to be odd, remember? Therefore, everything on the left will be like this. Okay, and keep going and keep going. From here, you can see this one forms a perfect wave. We call it a sine wave. Roughly, that's how we did it. Okay, by analysis, it's not exactly accurate. To see the exact procedure, let's use some computer graph. Okay, and let's do the thing. And you can see, okay, as your t become bigger and bigger and bigger and bigger on the unit circle, your whole thing just rotates. Your sine value become bigger and bigger and bigger, smaller, 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 smaller. Sine become negative, and then -1, then you come back. All right. Now, we just want to record what we have here, but we want to copy your sine value. Then this is what you got. And you can see the whole thing start to repeat itself. Every time it hits a 2 pi, it restarts the process again. Let's do it again. And clearly it's a wave. Okay, now for the left, you basically flip the whole thing. You will have a wave which just continues, just keep going. Similarly, you can do the same thing for cosine. We skipped the part in the book, but basically it's the same process. Except remember, see the orange line here? You're recording the x value for cosine. But you can see roughly it's the same as sine value, which is not a surprise because if you take the whole unit circle, you rotate it by 90 degrees, then your x become y, right? So if you have an iPad, you turn your iPad by 90 degrees, you can see this is nothing but exactly the same graph as before. All right. That's how we do the graph of sine cosine. But at first, we have a sine wave. All right. So number 3. Let me write down what your sine wave is. There are several things you want to be careful, especially if during the exam or in real life, some people ask you to draw the graph of sine t. Let's use t. Actually, just use x. I think we're past that point for now. The first thing you want to show people is, you want to tell people it's between -1 and 1. So you need to show these two. Second, you'll need to show people, okay, the period. So it's from 0 to 2 pi. And usually you need to show people the 5 special points because they're really easy to draw. That is where you start, where you are at the peak, where you are in the middle, at the lower peak, and this. Once you have all these, connect all the points to draw the sine graph. You don't have to draw it to be super accurate, but just to show the trend. It's a wave, it's smooth, and it oscillates between these points. Now, to show people that this is periodic, I would suggest to draw another cycle with the same graph, then people know, oh, it's a periodic function. Do a little bit so to let people know it's still continuing. And finally, on the left, you need to give people at least one complete cycle. To let people, to see this is odd function. And I know this one just continue forever. So this is the complete graph of y equal to sine x. Include the maximum and the minimum, the 5 special points. Okay, you better label them. And at the last, show people it's periodic by drawing another period. And then it's odd by drawing the left part for just one period. I think is sufficient. All right, that's everything about sine curve. It's a wave. Let's talk a little bit about the cosine graph. Okay, we will write down several things. Number 1, it's from -infinity to infinity to -1 and 1. Same thing as sine graph. It's an even function. Okay, and it's a periodic function with the same period, 2 pi. Now, if we draw some special points, we do the same thing, but this time we have cosine. So 0, pi over 2, pi, 3 pi over 2, and the 2 pi. Remember, we'll pick those points because they are so easy. They are nice numbers. Okay, then what we have, and remember, the first one and the last one is going to be the same. Okay, 1, 1, 0, 0, -1. So that's what we got. Let's draw these 5 points. -1. So now use the same argument as before, increasing, decreasing. We can have this. Do another one. A little bit further. And then remember, this is even. Even means you don't simply just take this and just do, rotating for 180 degrees. Instead, what you do is you just simply mirror it. Okay, see that this is also a wave. Okay. This is the cosine wave. Moreover, this looks exactly as the sine wave. The same shape as sine wave. Except for sine wave, you start from this point. If you go back, you need to shift everything here to B and start from like this. But for cosine, it's the same wave, but you start from right in the middle, which is where pi over 2 is for sine. But you start from 0 for cosine with the same wave. Okay, it's no surprising this is the same shape, because as we draw before in the computer graph, sine basically are trying to record the y value change as this point change going from here. Just keep moving, and then your sine become like that. Okay. Now for cosine, what you're trying to do is you're letting this point to move, but then you're recording this for your x value. From here you can see if you rotate this one for 90 degrees, you got exactly the same sine value. Therefore, they should have the same shape. Same trend, okay? Same bend, same steepness, same shape in general. All right, that's everything about sine and cosine wave. So if we put them together, they're exactly the same, except they have different points. Okay, for sine, you start from here. For cosine, you start from here, okay, which is technically shifting the sign to the left by pi over 2. Okay, that's what you have for cosine. All right. Now, number 3. This is nice. We have a nice wave that describes a certain kind of thing. Now, in real life, what kind of wave can you see? Well, number 1, you're not going to see 2 pi probably for the period all the time. You may see some very sharp wave. You may see some like very slow wave, which is like the tide. You may see very big waves when you have a tsunami. We have a very small waves, which sometimes is just like a wind blowing at the top of the lake, which only give you very small vibrations. Okay, we have all these kind of waves, but now what I want to say is they can all be represented by a variation of the sine wave. Okay, so let's talk about the variation of sine and cosine waves. Probably just sine. The reason we're trying to do this is you have so many waves in real life, and you must be really lucky that they look exactly as a single sine wave. Usually it's a variation. Okay. Now let's see what kind of variation we can have, starting from sine x. I'm just drawing one period because you know it repeats, so I don't have to draw all of them. We just want to see the variations. Okay. Another thing to think about is actually, before we go ahead, think about what kind of waves do you see in real life. Just give yourself something to hold on to. Real life waves. Sound. Okay. You can see the wave in the lake, so tide in the ocean. Earthquake. Okay, light, signal. They are all waves. Light is a wave. Okay, electrical waves, sonic waves, all those kind of waves. Sometimes even though you cannot see, but basically whenever there is a vibration which is traveling, you do have a wave. Okay. So for our class, we will just focus on sound and let you know, okay, how different sound changes. So the first kind of thing we need to think about, starting from here. You have a sound. Basically, it's roughly like, oh, just keep going. So that's your sine wave. Now what you want to do is, you want to make your sound louder. Instead of saying hey, you say hey by making it louder. This corresponds to something called the amplitude, which go from here to this one times a number. Okay. We have seen this before. Okay, that is called function transformation. If you try to recall, we have 3 types, and we are going to use the 3 types. Okay, the first one is called amplitude. So This A is called amplitude, which will make your voice louder, so it affects the volume of your sound. The bigger the number, the bigger the sound, of course. So for example, if you have y equals 2 sine x, what will that thing change? That would take all the value and double it in the y direction. Therefore, if this is the original sine wave, this new thing will go from -2 to 2, which gives you the same sine wave, but like this. Okay. Similarly, if I give you 1/2, if you times a 1/2, that will actually make everything half the size in the y direction. Okay. So by tweaking this number, you will make this one louder than the original sine, or make this one actually quieter. And that is called amplitude. If you play music, you know this one can be changed by amplifier. That's exactly what it does. It takes a sine wave, make it bigger or smaller in terms of the amplitude, which is in the y direction. Okay, so that's the first concept, the amplitude, which is what we have in real life when you play music. Okay. Second thing, this time we don't want to squeeze or stretch in the y direction, we want to squeeze and stretch in the x direction. So if you have something like this, which is the original sine wave, I very well want to do the same thing, but within a shorter period. By squeezing it, or in another word, you have some wave looks like this. I want to either make it more wider, or I want to make it really oscillate really quickly. Okay. That is called the frequency, or the period. They're actually exactly opposite, flipped of each other. So let me write it down. A high frequency. Let me write this. Frequency and the period. Depending on the definition, sometimes we use different things. But the general principle is if the frequency is high, the period is small. That means it only takes you a very short period of time to complete one cycle. And if the frequency is really low, for example, for earthquake or big tide on the ocean, the period is really large. It takes you probably 50 years to complete one cycle. Okay, for some, we won't call it earthquake anymore. Earthquake is actually faster than that. Okay, so basically what we have here is low frequency. This is the high frequency. Now referring to sound, okay? High frequency give you a higher pitch, and the low frequency give you a low pitch. So say if you have a very small period, a high frequency, your sound is more like sharp, like a train coming over, okay? And when you say a low frequency, that means your sound is really low, like, I don't know, explosion? Explosion is probably low, or like, I don't know how the bison sound, it's roughly a low pitch, okay? Now how do you change that from this? Now we know. From function transformation, you simply multiply a number on your x. Okay? Now keep in mind, let's draw it, actually. Let's draw it. This is the original sine wave without changing a thing. The period is 2 pi. Okay? Now what do? What you do is you times an a there. So you squeeze, or let's say shrink, the whole function by a. Okay? If you don't know this go back and review something in college algebra on function transformations, I think it's in your notes. It's called shrink by a, which is kind of different. Before, if you have a in the y, you stretch, but for this one, you shrink. So for example, if you take y equals sine, but you have a 2x here, that means shrink the whole thing by half. Then whatever happens here should happen here. By the way, keep the y the same. You basically do the same thing within half the period. So the whole thing has a higher frequency, a smaller period. Okay. But now what if you put a 1/2 there? That means shrink by 1/2, which means stretch by 2. You cannot shrink something by 1/2. Okay. Therefore, if this is the original thing from 0 to 2 pi, the new thing, once you put a 1/2 there, is going to go from 0 to 4 pi. From here you can see, putting a number here right before the x, you horizontally shrink or stretch the original graph. Reflecting on the physics, what you have is you change the frequency or you change the period. So, it's very easy to do. If the original period is 2 pi, now you shrink it by a, your new period is just going to be 2 pi over a. For example, if you shrink it by 2, then your new period is going to be pi instead of 2 pi, which is half the size before. If you shrink by 1/2, which means you stretch by 2, so before it's 2 pi, now you should stretch by 2. To do the same thing, you need 4 pi. Okay, so that's the formula for the period. Okay, finally, the third thing, which is a phase shift. This doesn't change your sine at all. But just imagine, you have the same sine wave. Okay. Maybe you just listen to a music which starts from the beginning. But now what you can do is you don't have to actually start from the beginning. You can take the same wave. But this time what you do is you listen halfway. For example, you listen from a song and you just skip the first lyric. Right, start from the second part. So there's no guarantee you always start from the beginning. So what you did is you basically didn't do anything. You keep the same sine wave, same frequency, same amplitude, but you simply just do a phase shift. Horizontal shift of the graph. That's something you can do. Okay. Now how do you reflect that? Well, we have done this before. That go from here to y equals sine x plus a b plus a. Sorry. We know this is by function shift. That means shift to the left by a. Okay. For example, y equals sine pi over 2. X plus pi over 2. What is it? Well, if this is sine, and this is pi over 2, 1, then it means take this graph, shift to the same thing to the left, but exactly the same graph. Similarly, if you put a negative number here, that basically means shift to the left by a negative number. That basically means shift to the right by pi over 2. Okay, very easy to understand. The only thing start to become a little bit confusing is when you have a number and a shift together. For example, 2x plus pi over 2. Now, you do have a choice. Do you want to shrink it first by 2 first, and then shift to the left by pi over 2? Or do you want to shift to the left by 2 and then shrink it? These two actually give you different answers. As far as you remember, okay, from function transformation, remember you have something like y equals f, ax plus b. Really, you need to do things in a certain order. So there are two ways of doing it. The first one is you just simply do this. You remember, you always shift first. Shrink later. That's just the rule. You can remember that. We do have some reason behind that. If you want to review, go to your college algebra notes. Or another way you think about it is just you simply just do this. You do know this one starts from 0, right? That means if you plug in 0 here, you should have 0. Now if you have the new thing, you know you shifted everything, but you still start from something 0, which is where this one starts. You just wonder where this point will be, because then I will know how much I need to shift. And that, you simply just set this one to be 0, which gives you 2x equals negative pi over 2. You got x equals negative pi over 4. Okay. So if originally you start from 0, this time you start from negative 4 pi over 4. You shift everything to the left by negative pi over 4. So you don't have to remember any orders here. You simply just solve it. Okay, that's the 3 variations you can have for a sine wave. Then you can start to make some wave look like this, which you need to shrink first, maybe shift a little bit, maybe amplify a little bit. That should give you every single waves you need. Let's see some example. Before you do that, let's write down everything. Okay. So the general sine wave should include these 3. That is y equals a sine kx plus b. Okay. Now starting from here, you should be able to read the amplitude, okay, the period, and the phase shift. Which come from kx plus b, therefore to give you x equals negative b over k. And once you read these 3 informations, you will be able to draw the graph. Let's see what we mean by this. Okay, example. Draw the graph of y equals 3 sine 2x plus pi over 2. Okay. Now we know the graph is roughly like this, maybe shrinked, okay, amplified by 3, and things like that. But let's first write it down. Amplitude. Which number? 3. Okay. Period. 2 pi over 2, which is pi. Finally, phase shift. Okay, that is going to be negative k over b over k, or simply just set this to be 0. All right. So how do we draw the graph? Let's think about several things. Number 1. This is the original sine graph. Okay. Now what will this do? Number one, it will change this to be from -3 to 3 due to this 3. The whole thing become amplified. Second, before you have a whole period of 2 pi, but now you have a period of pi. What you need to do is you need to shrink the whole thing. You want to complete the same thing within half the period. So you need to start from here and finish here. Number 3, the whole thing does not start from 0 anymore. It starts from -pi/2. So finally, you have to take this green one and shift to the right by this much. Okay, let's say it again. The 3 amplify everything. Okay. The 2 make your period from 2 pi to pi. Finally, the -pi/4 shift everything. So this one is actually the green operation. This one is the red operation. And this is the blue operation. One after another. Okay. Which is kind of confusing, right? So we can do things in this way. You can draw it. Try your best. Or we can take a detour, which I personally think is faster. Okay, so this way is working if you want to do it. But what I would do is, I would do this. This is sine x. Remember, for a wave, what we really care about is just these 5 points. Do you know them? Well, it's 0, 1. Or let's say vertically it's going to be 1, 0, -1. Horizontally it's going to be 0, pi/2, pi, 3 pi/2, and 2 pi. Now you squeeze, you shrink, you stretch, you amplify, whatever. But no matter what you do, what do you want? You still want 5 points. This time they're just in different location. Number 1, the 3 will change this from here to here. Easy to do. Okay. Horizontally, what will they do? Well, they start from -pi/2, pi/4 for your phase shift for the first one, for sure. And you want to complete the whole thing within a pi. That's what you want to do, right? All right. To have 5 points, do you realize going from here to here, every time you just go pi/2, you will get the next one? The reason is because if you do this for 4 times, you got exactly 2 pi. That's your period. This time you want to do something for 4 times, and you got a pi. So each step is going to be pi/4. So if you do that thing for 4 times, to go from here to here, here to here, here to here, to here to here, you will receive a pi, which is exactly the period you want. So then you start from -pi/2, you go a pi/4. It's a 0, another pi/4, another pi/4, another pi/4. What do you got? You got from here to here, you did pi/4 for 4 times. Therefore, you got a whole period of pi. You start from here, which is your phase shift, you completed your period. Now, in order to draw, you just need to reflect these 5 points. Okay, the first one, -pi/4. The second one, 0, 3, pi/4, -3, let me use red. First one, second one, third one, fourth one, and the fifth one. Now after that, number 1, check. Do you have a period of pi going from -pi/4 to 3 pi/4? Yes. Do you have amplitude 3? Yes. Do you start from the phase shift? Yes. Ha. Okay, that's the best I can do. And then complete another cycle, roughly. Okay, so this is what I propose. Instead of going this kind of shrinking, shifting, and whatever, which is ugly, what we do is simply we find the coordinate of the 5 essential points. Okay, after we do the transformation. And number 1 is from -1 to 1. You change the y by doing the amplitude. Number 2, you always start from the phase shift. Number 3, you always want to complete a whole period within 4 steps. Therefore, take your period divided by 4. Starting from this number, go for that steps for 4 times. You will get the completed period. Okay? Once you have the 5 points, you will be able to draw the graph, and then after that, it's standard. So in the exam, you can pick either way, but I do want you to write down the coordinate of the 5 points. So I know you know how to do this. You did it accurately. That means you need to show me clearly, like what I have here, even though I didn't write down this one is actually 0, 3. But the way I draw it, you can clearly see it's 0, 3, right? So you need to give me the coordinate of these 5 points. It's essential. So I know you know how to draw the graph. Let's try another one. You can pause the video and try by yourself. Try to see does your answer match mine. Okay. Amplitude. Two. Period. 2 pi over 3, which is 2 pi over 3. Phase shift. 3x minus pi equals 0. X equals pi over 3. Okay. Originally, okay. Now the new one. Number 1, amplitude, 2. Number 2, phase shift. Therefore, the first one has to be pi over 3. Number 3, you want to complete your period in 4 steps. So each step is going to be this one divided by 4, which is 2 pi over 3 times 1/4, which is pi over 6. Therefore, starting from pi over 3, which is, let me write it down, pi over 3, which is 2 pi over 6, right? You go pi over 6 for every time. So 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay? And there's a guarantee that when you finish, you have a whole period of 2 pi over 3 because you did it for 4 times. Then, simplify a little bit. The first point is this. The second point is pi over 2. 2 pi over 3. And the pi, this one cannot be simplified. It doesn't have to be exactly accurate, just so try your best. Pi over 3. Pi over 2. 2 pi over 3. 5 pi over 6, and pi. In this way, you clearly showed me the coordinates of the 5 points. So I think that will be good enough for the example. All right. You will see many more examples in the web work. So I will stop here. The key is always try to find the 5 points. Okay. According to my experience, sometimes people get confused on why we do this. So make sure you understand why do we divide the whole thing into 4 steps and do 1 step each. Once you understand that, the whole thing will be straightforward. All right. The last thing, which we will briefly go over, that is, if we know the formula, we can get the graph. But now can we get the formula from the graph? This is very easy. So I will just go over one example, but you can try many more. It's basically doing everything we have done before, but reversely. Okay? So this is what I have. I have a sine wave. Okay, moreover, I will tell you some points. This point is pi over 2, 1.5. This point is pi over 4, 0. And this point is 5 pi over 4, 0. With all this information, you can have more points if you want to go ahead and try to measure. But with all the information, what's the graph? Oh, what's the formula of the graph? Okay, that's the idea. So now you can see it's exactly the opposite of what we have just done. But basically, the bridge is still try to recognize what's going on. Okay. By the graph, can you tell me what the amplitude is? That's going to be 1.5, right? Before, you go from -1 to 1. Now this one can go as high as 1.5, so 1.5. Do you know your period? And that is going to be going from pi over 4 to 5 pi over 4. That's when you complete one cycle, right? So together, it's going to be which is just pi. Phase shift, that's where you start. Pi over 4. That's what you read from the graph. Now in order to put it into the formula, which look like this, right? Now remember, this one is a, if we know the formula, this one is going to be 2 pi over a, and this one is going to be negative b over k. Oh, did I use a or k? 2 pi over k, okay, this is 2 pi over k. Good, good. So actually to figure out the point is try to figure, the graph is trying to figure out a, k, and b. But by what you read here, you can actually go ahead and solve for a, k, and b. So from the first one, a equals 1.5. From the second one, k equals 2. Then 2 pi over k is going to be pi, which is what you observe from the graph. Then this one is going to be negative b. This time you know k. From here you can see b equals negative pi over 2. So together, that will be the graph you're looking for. From here you can see it's very easy to recognize the physics properties like amplitude, period, and phase shift from the graph. How do you do it? Number 1, focus on the y. As long as it's not from -1 to 1, it's for some other number, that's your amplitude. For period, you just look for one complete sine wave and see where it starts, where it goes, and how long it took them to go from the starting to the end. In this case, it's pi. Finally, the phase shift is just where you start. In this case, pi over 4. Once you have that, you also know they have some relationship with a, k, and b. So write them here, and then start solving them by solving the algebraic equation. Amplitude is easy. Period is not hard. One thing to keep in mind is to do the phase shift, you need to know both k and b, which you cannot solve right away until you have finished what k is, and you get that thing from the period. So, period first. Once you know that, you know k, you can go ahead and try to solve the phase shift. If you reverse the order, you don't have enough information if you start with phase shift first. Alright? That's all for the graph of sine and cosine. Try some examples.